Hello. In this tutorial, I will discuss the key considerations when modelling chilled water loops. I will show you how to add a chilled water loop with fan coil units by loading a HVAC template, and then review the edit dialogs for the loop and the system components. In this tutorial, I will focus only on the chilled water loop and won't repeat the general loop and system characteristics mentioned in the earlier hot water loop tutorial. Chilled water loops provide chilled water to cooling coils in components such as air handling units, zone air distribution units and chilled beams, and also to the pipes in chilled ceilings. I will now go to the HVAC system and load the fan coil unit 4 pipe air-cooled chiller template. I will add the system to all zones. I won't review it here, but note this Override Template Default option that enables you to set some of the main system parameters. The default chilled water supply subloop includes a single chiller, splitter and mixer, a circulating pump, and a set point manager. I will now review the edit dialogs for the system components, starting at the chilled water loop level. Much of the data on the chilled water plant loop dialog is used for sizing to ensure that the loop can meet the loads created by the connected zones. The default loop flow temperature used to size the loop is set to 6 degrees Celsius, with a relatively small differential of 4 degrees Celsius. This gives a return temperature of 10 degrees Celsius. You need to make sure these inputs reflect your system design temperatures, as they can have a significant impact on efficiency, energy, and carbon emissions. The outside temperature operation option allows you to restrict the external temperatures below and above which the plant or condenser loop will operate. This control can help prevent the plant cycling at very low loads. The temperature range should be set according to the type of plant loop. Going to the Chiller Edit dialog, you can select the chiller model from the library or use the air-cooled default chiller. You can also copy and edit a template or add your own. The electric EIR chiller type option enables the simulation to model the effect of variable efficiency during part load operation by using the performance curves loaded with the chiller template here. Both the reference capacity and chilled water flow rate are auto-sizable. Consider initially leaving everything set to auto-size when setting up the model. Once you've confirmed that the HVAC system runs correctly, you can then start to modify the sizing inputs and check results systematically. As mentioned, the performance curves are loaded by default with the chiller template. You can load your own chiller details and curves if required. See the program help for more information. The supply subloop includes a set point manager, which acts as the main system controller during the simulation. The set point manager specifies the set point, in this case for the CHW flow temperature node, which is used in the loop as a goal for controller actions. The default set point manager schedule is set up to control the off-plant temperature at a constant 6 degrees Celsius, which is consistent with the temperature used to size the chiller in the loop edit dialog. There are other control types available. The pump control type can either be constant or variable, depending on the setting made at loop level. As I have now added cooling to my system, I should go to one of the zones in the zone group and check that the zone cooling sizing defaults are suitable. The cooling sizing factor here is based on the ASHRAE standard. I will leave it set at default. I haven't changed any of the fan coil units, so can check these in any zone, knowing that they will be the same in all zones. Energy Plus fan coil units are small, self-contained, in-room forced convection hydronic units that use water as the heat transfer medium. The 4 pipe fan coil units in Designbuilder provide both heating and cooling. You can model a 2-pipe unit, providing only heating or cooling, by navigating to the appropriate coil and setting its availability schedule to off. There are 4 options available to enable you to define how the fan coil unit output is controlled by varying the air and water flow rates. Most of these are self-explanatory. 2 fan control types are available. The default on-off fan will cycle the fan on and off with load. The constant volume option will keep the fan running when scheduled on, regardless of the load on the fan coil unit. The fan coil unit is scheduled on by default, so it is available to operate on demand according to the Model Data HVAC tab heating operation schedule unless restricted elsewhere. Restricting heating or cooling at specific times or dates can be achieved via the appropriate coil availability schedule. By default, editing a zone component affects only the currently selected component. However, on this tab, I can select other components within the same HVAC zone group, which require the same data as the current component. The cooling coil type option enables you to enter detailed parameters for the coil if required. The least complex coil options are set by default for the coil and analysis types. Similarly, you can edit the properties of the heating coil and the supply fan. This finishes our quick review of chilled water loops, chillers and fan coil units in Designbuilder. If you want to learn more about the topics introduced in this tutorial, including top tips that will improve your modelling efficiency, then our chilled water loop and air loop with fan coil unit on-demand online training session explores this in more detail. We hope you found this tutorial useful. Further information on the specific topics and wider application areas can be found in the comprehensive Designbuilder program help, other tutorials and webinars, and our on-demand training.